Well, hello and welcome to the AFS Technologies monthly learning series. Thank you to all for joining us today. My name is Ian Faith and I will be hosting today's session entitled Machine Learning and Retail Execution, Data Science Applied for Increased Effectiveness. In today's presentation, Andres Hehen, Product Management Director for Retail Execution at AFS, will be presenting. With all the data available these days, the decision-making process at all levels has become a cumbersome task. Only few people in each organization understand the relevance of the information gathered and are able to define the strategy to follow to be successful at the shelf. With machine learning, the process of analyzing great amounts of data gets significantly easier and the information is made available to all members in the organizations. Hence, proper decisions are made and strategies are deployed to the field faster and more accurately, since machines will help to predict the outcome of such strategies. In this webinar, AFS Technologies will discuss the innovation behind machine learning process, how we are teaching computers to think and to sense things the same way humans do, and how machine learning helps retail execution by enhancing retail activity optimization processes in the identification of common patterns at the store and how it helps to predict what to do next in order to increase revenue and effectiveness. Andres, thank you very much for taking the time out of your busy schedule to be with me today.
Thank you so much, Ian, and good morning to everyone. Good afternoon, depending on your time zone. As Ian explained, in this webinar, we will cover the aspects around the innovation of machine learning and how machine learning will help us in retail execution to be more effective in the field.
Great. So let me tell you guys a little bit about Andres. Andres Hehen, as I say, is the Product Management Director for Retail Execution at AFS. He's an executive with 14 years of experience in consultancy, implementation, development, and support of retail execution solutions and Salesforce automation. All of his career has been devoted to software and solution delivery for Salesforces in the Americas and Europe. Before joining AFS, Andres worked for several pharmaceutical companies on their strategy for mobility solutions and accompanied the transformation process from the traditional pharma promotion approach into a more CPG-esque way of work that is now current trend in the pharmaceutical space. Andres holds a degree in Systems and Technology Engineering from the Universidad Distrital Francisco Jose de Caldas in Bogota, Colombia. So with that, Andres, I will turn it over to you for the webinar.
All right, thank you very much, Ian. Okay, so let's speak a little bit about the history of machine learning and what machine learning is. Machine learning has been around for a while. It goes back to 1959, when it was defined as a field of study that gives computers the ability to learn without being explicitly programmed. In traditional computing, you need to write code for your program in a deterministic way in order for that program to provide the outcome required. For instance, you can write a piece of software to calculate a tip. It will receive the inputs, such as the number of parties, the total amount of the bill, the typical tip percentage, perform the calculations that are explicitly written in the code, such as dividing the amount of the bill into the number of parties and then applying the percentage, and then provides the result, which is the tip amount. With machine learning, we have a different story. We provide our computers with raw data, and the system will return back to us a result that is based on its own experience and learning. Think of it as a computer thinking the same way a human will do. Taking the same example of the tip, in machine learning, we will provide the system with a number of non-deterministic inputs, such as raw data for bills and tips in the country, and then the application will analyze a number of variables that may be unknown to us, such as the average tipping in the region, average tipping received by that particular server, typical tip coming from a number of parties similar to yours, and so on. And it will provide a result that will be far more accurate given the amount of variables involved. Another key aspect of machine learning is that the system keeps learning from time to time the same way humans do. Now let's review with an example how machine learning can be applied. This table that you are seeing in the screen portrays a specific list of transactions that have been labeled as fraudulent or not. Let's review this data. With this data, it's immediately obvious that our first guess as a pattern, right, is that everyone whose name starts with a P is a crook, right? But it turns out that the customer Pali here doesn't have that pattern, doesn't fit into that pattern. In the data also shown here, you can see the customers in their 20s have a high fraud rate, right? But then we can look at customer Smith. He doesn't fit into this pattern, right? Okay, and they may be a combination of things can be used to detect fraud. How about those customers whose card was issued in the USA, used in Russia, and are under 20s? Well, wrong again. The customer name Norse violates this rule. The truth is that the pattern that this data supports is this. A transaction is fraudulent if the cardholder is in his 20s, the card was issued in the USA and used in Russia, and the amount is more than $1,000. With some time, you probably have figured this out, since the data you have to work with isn't very large. But suppose that you don't have not just 10 records, but 10 million. And suppose that for each record, you don't have only 6 columns of data, but 60 columns. There's probably a useful pattern hidden in that data for determining which transactions are likely to be fraudulent, but you'll never figure it out by manually looking at the data. There is just too much of it. Instead, you have to use statistical techniques, approaches that are designed for finding patterns in large amounts of data. And you'll need to apply those patterns and techniques to the data by running them on a computer. And this is exactly what machine learning process does. It applies statistical techniques to large amounts of data, looking for the best pattern to solve your problem. It then generates an implementation, which is a piece of software that can recognize that pattern. This generated code is referred to as a model, and it can be called by applications that need to solve this problem. With fraud detection, for example, the calling application must provide the right information about a transaction, such as age, amount, where the card was issued, and when it was being used. The model created through machine learning then returns an indication of whether this transaction is likely to be fraudulent. Now, how can machine learning be applied to retail execution? There are two basic approaches, through the analysis of raw transactional data or by the usage of perceptual intelligence, which I'll discuss a little bit later. The ultimate goal of applying machine learning in retail execution is to be able to find patterns in the data in an automated way that can help us to predict what is going on and what is going to happen after specific actions are taken. Fortunately, retail execution through AFS solutions provides very rich sources of data. And the next logical step is to analyze the data the same way we did in the previous example. In that way, we have here sales, inventories, deliveries, visit results, promotion executions, user location data, and in general, a large ensemble of data sets with certain columns in common. The big advantage in AFS retail execution is that all this data is contained into hierarchies, so it's easier for the machine learning process to slice it in order to find the necessary patterns. Hence, the machine learning software can determine the exact impact of a promotion in a complete store chain by evaluating the sales and finding the right pattern for increased orders due to the promotion execution. Another example will be to be able to determine the productivity of a sales process with an individual store in band sales. If even after including the store in a loyalty program, the sales are not increased and the drop size keeps somewhat steady on the low side, maybe it will be required to change the strategy with that particular store, or even direct it to be serviced by a third party rather than investing direct associate time. Another application for machine learning is to go hand in hand with retail activity optimization. It is crucial to every organization to identify which points of sale have to be visited, on which frequency, and what has to be done at each visit. It comes down to where to go and what to do. and we can just rely such responsibility on our sales rep directly if we want to follow a corporate strategy that will bring us the best results. The typical approach around both of these matters has been to either A, create a route directly associated to a user in which the geographical convenience is the most important, if not the only parameter, to determine the visit sequence, or B, to define a strategy of actions that will occur in the majority of visits, regardless of what are the immediate needs of each store. However, with the implementation of AFS solutions for this, the approach has changed, and the results are right now visible. Instead of defining a route that is mindlessly followed by the reps, all of our users have the possibility of influencing the route and to visit stores outside of a predefined plan if the need comes to it. On the other hand, the actions to happen in a visit are targeted, focalized, and made available to the end users in a way that when a visit is started, the user will know exactly what to do. But in order to implement the most effective optimization, human intervention alone may not suffice. It is necessary to get assistance from software to analyze all data available. And here is when machine learning comes in handy. By analyzing data coming from multiple sources, such as retail inventory, sales trends, last visit results, new promotions coming, users availability, store frequency, and so on, the machine learning software is able to predict when is the best time to generate a visit to a particular store and to place such visit into the user plan in a seamless way. And this can be even taken one step further. Machine learning can create a visit and then determine if a person is available in the area with the necessary skill set to complete such visit. Hence, the routing process can be made even more dynamic from going to steady territories and routes into a model in which the job is distributed more evenly and efficiently. But it's not only about the plan. For each individual visit, and again, based on all the available data, the machine learning software will be able to deploy a list of necessary actions to be completed in the store. For instance, if there is information that a delivery will come on a specific date, the system will automatically trigger an action to restock the shelves right after the delivery has arrived. Another example may be that if an out of stock is detected constantly in a group of stores for the same products, user will have an order guide automatically generated to cover the products that are identified. Finally, machine learning can help users in the process of deciding what kind of data is available. For example, the software can automatically send alerts of forecasted sales trends declining, notify about the availability of new promotions, and automatically putting the necessary support material for the promotion available for the users, such as sales sheets, store layouts, planogram images, etc., reducing the overhead in management of the system while increasing the accuracy on the direction of the data. The second approach in machine learning is what is known as perceptual intelligence. If we consider that with machine learning we are teaching machines to learn the same way we do, with perceptual intelligence we are teaching them how to sense things the same way we do. One good example of this is the process of digital image recognition, which is already available in the AFS solutions. Through digital image recognition, an image of a shelf or any other product location is taken, and a learning machine is able to identify and discern from the image what products are present there. This has helped greatly to reduce the time spent in auditing the stores, enabling the reps to execute more and increase their coverage with the extra time. But the image recognition is not limited to discern what is present in the image. Sometimes, after a picture from a store is taken, we realize that there is a lot of garbage around it, meaning that some products that are not intended to be audited, or people passing at the moment of the photo, or some background data. Through a computer vision API, is it possible to create a perfect thumbnail out of an image in which the elements highlighted are only the relevant ones. It's like zooming into the picture, but also isolating from the image whatever is important and discarding the rest. This will conduct to more accurate in-store analysis based on images, while significant data space is saved by removing all unnecessary picture backgrounds. Another application of these perceptual intelligence algorithms that are embedded or will be embedded into AFS retail execution solution is the implementation of speech recognition. the machine will learn to recognize the voice of a person and will isolate keywords that can trigger actions in the retail execution software. So instead of pulling out a handheld and keying out an order, the user will dictate via voice the order to a wearable device that can be either a handset, a headset, or a smartwatch, right? Making the process of capturing the data in the store faster. Finally, machine learning and perceptual intelligence can be implemented to analyze results of store visits in search of keywords within nodes or specific points of data in survey results. By analyzing this data, the system can tell how stores or consumers are reacting to specific promotions or activities starting from non-deterministic data. Now it's time for a couple to get your questions, if anyone has formulated one.
Okay, guys, yeah, if anyone has a question, please enter into the questions pane in the control panel. And Stephen's collecting those right now. Andres, thank you very much. Very succinct. We have actually there's a couple here. Is this a technology that is already available?
Yes, this technology is available right now, although machine learning is a constantly evolving technology. New uses for this are being found on a daily basis, and it will depend on the needs of each individual company on how to apply the machine learning process into their own needs.
Okay. Actually, these two look like they're pretty similar. So yeah, you know, how many companies? Is there a lot of companies implementing this technology? And yeah, and the other one was how widespread is this usage? So yeah, could you address that?
Well, as I was mentioning during the presentation, the first and most common approach in machine learning is the process of digital image recognition. And this is something that is gaining a lot of momentum in the CPG space. Actually, our own AFS retail execution solution has already embedded this digital image recognition. So I have to say that the technology is being adopted fairly quickly, and since more and more users are discovered on a daily basis, I'm not going to be very surprised if this technology becomes very widespread.
Right, so you're talking digital recognition. Is that planograms and being able to do retail execution with planograms?
Precisely, to have the ability of taking pictures in the store about the various product locations, and then from the image discern what is present in the shelf and what the amount of facings do we have, and if the right assortment is there, and if the planogram is compliant, and if the shelf accomplishes the image of the perfect shelf, and so on.
Right, and when you were talking, actually, and this is actually a question from me, when you were talking about surveys in store using voice, is this something that a technology that's coming where, you know, people can actually do surveys in the stores audibly for feedback for retail execution?
Precisely, and it's not only limited to surveys. Actually, the whole intention of the perceptual intelligence around voice recognition is to be able to dictate to the solution what to do. So an application of that will be the user walking through an aisle and without having to pull out its device, dictating to the system, I have 4 facings of this product, 5 facings of this one, I have an out of stock on this one, the shelf looks good, and then the system will be able to isolate keywords from the dictation of the user. And out of these keywords, commands will be triggered in the retail execution application, and hence the user won't have to manually key in those inputs.
Right, excellent. Well, thank you very much. That concludes our questions for today. If you could go to the next slide for us, Andres. Thank you very much to everyone for being with us today, and for Andres, for you taking the time to be with us. On behalf of AFS, thanks very much. If you want to get in touch with Andres, his contact details are here on the screen. And again, you will be getting a copy of this presentation as well. On behalf of AFS, thank you for taking the time to participate in today's webinar. As a reminder, again, we will be sending out a copy via email in the next few days. It should be within 24, 48 hours with a download link to the full presentation. Other complementary resources are available from AFS on our website at afsi.com. Also look forward to following us on LinkedIn and being part of our LinkedIn community. And again, thanks everyone for joining us. Until next time, enjoy the rest of your week. Happy Easter week to everyone, and goodbye for now.